Welcome to Avatar Technology Digest, and here are the top stories of the last week. As always, we start our digest with incredible news on technology, medical cybernetics, and artificial intelligence. Man with a complete spinal cord injury learns to walk again. Researchers create a bionic exoskeleton that allowed a paralyzed man to walk again using his own brain waves. Researchers hooked a paralyzed man up to a device that would receive electrical signals directly sent from the brain and transmit them to electrodes surrounding his knees, giving him ability to move once again. The man learned to operate the system by first wearing an electro-EEG cap that reads his brain waves as he visualizes moving an avatar in a virtual reality environment. Scientists say that this is the first time a person with a complete paralysis in both legs has been able to walk without manually controlled robotic limbs. Even after years of paralysis, the brain can still generate robust brain waves that can be harnessed to enable basic walking, say researchers. This non-invasive system for leg muscle stimulation is a promising method and is an advance of our current brain control systems that use virtual reality or a robotic exoskeleton. The authors also note that they might be able to use a simplified version of the current system as a means of non-invasive rehabilitation for those with an incomplete spinal cord injury. Mind reading is possible. Researchers from the University of Washington successfully sent thoughts over the internet in an unprecedented mind-reading experiment that shows two brains can be linked directly to allow one person to guess what is on the other person's mind. For the experiment, volunteers played a game similar to 20 questions, wherein one player thinks of an object and the other player tries to guess what it is with a series of questions that the first player then answers with a yes or a no. One of the participants, the respondent, located a mile away, was outfitted with a cap connected to an EEG, which picks up signals from the brain and records brain activity. The other participant, the inquirer, was also outfitted with a cap with a magnetic coil placed behind the area of the brain controlling the visual cortex, which processes visual information. The no answers send a signal to the inquirer and activate the magnetic coil, but only yes can generate an intense enough response to stimulate the inquirer's visual cortex. If the answer is yes, the inquirer will see lines, spots of light called phosphenes, indicating the affirmative response. There are no corresponding phosphenes with no answers. The participants managed to guess the correct object in 72% of the games with the method. In contrast, they were able to get the answers correctly 18% of the time when they guessed by chance. You might be ready to write off 3D printing as one of those technologies that never really lived up to the initial hype, but it's beginning to prove its usefulness in a host of medical treatments. American researchers developed 3D printed scaffolds that can encourage damaged human nerve cells to grow back. The team started out by designing the 3D scaffolds in shapes that the original nerves were laid out in, so they could act as pathways or signposts for both the sensory and motor functions of complex nerves to grow back through. The scaffolds themselves are made of custom silicon and implanted with biomechanical cues to help encourage growth. So far, the process has been tested in rats, but signs of improvement in the animal's walking abilities were noticed after 10 to 12 weeks. Now, the researchers are hoping humans can benefit from the same approach. Our nerves are notoriously reluctant to grow back after injury and only repair themselves very slowly, if at all. Using a structured light 3D scanner, the scientists were able to create copies of the layout of the nerves inside the body and then build scaffolds accordingly. These scaffolds then linked two ends of regenerating nerves together, bridging the gap between them. Each branch of the object can have a different chemical makeup if required. The scanning and printing process takes about an hour. The researchers were able to get human nerves to hold up reasonably well inside the scaffolds after a period of several weeks, but only in a dish rather than an actual body. Scientists have identified a protein that helps heart muscle cells regenerate following a heart attack, and a patch packed full of these proteins and placed directly on the heart was shown to greatly improve cardiac function and survival rates in both mice and pigs. The researchers believe the protein patch could be tested in humans in 2017. Animal models that suffered heart attacks and were treated with the patch regained close to normal function within 4 to 8 weeks. The protein follistatin-like 1 was found to stimulate cultured heart cells muscles to divide. In animal models that had undergone an experimental form of myocardial infarction, a patch that applied these proteins proved to rebuild the damaged heart tissue and reduce scarring, two factors that current heart attack treatments fail to address. To make their findings, the researchers looked at the way fish naturally regenerate heart tissue by producing regenerative compounds in the heart's outer layer. By looking at epicardial cells, the team demonstrated that they stimulated existing heart muscle cells to replicate. They identified the protein responsible for this phenomenon using mass spectrometry and high-throughput assays. Using this information, the researchers created a therapeutic patch made out of collagen that was cast with Fiestel-1. Google and Boston Dynamics' latest robot is now going through basic trainings with the US Marine Corps, which recently recruited the RoboDog for field trials. Spot, the four-legged robot, can trot on a smooth surface, navigate a variety of terrain with ease, and maintain its balance even when being kicked. DARPA robotic engineers accompanied the Boston Dynamics robot to the Marine Corps base in Virginia, where the robot worked alongside soldiers in several test combat situations. Spot was required to scramble over rocky hills, walk through woods, and make its way around an urban environment. Spot also acted as a scout, a role often filled by a working dog. In these tests, Spot entered a building before the Marines with the goal of identifying any potential threats. Besides its uncanny ability to scramble over obstacles, Spot also is safe to operate as it's wirelessly controlled using a game controller connected to a laptop computer. While the robot is exploring a dangerous area, the operator can remain at a safe distance, controlling the robot up to 500 feet away. The operator also doesn't need a line of sight for the controls to work, a useful feature that allows the robot to move along the optimal trajectory necessary to complete its mission. What's the future of drones? In a snazzy new video filmed at Zurich Flying Machine Arena in Switzerland, quadrocopters are shown flying around and putting together a very sturdy rope bridge that could support the weight of a human being. One of the big selling points of drones is that they can get to areas that are not exactly safe or accessible by humans. That's why watching quadrocopters assembling a rope bridge that's sturdy enough for a person to walk across is so damned awesome. It immediately calls to mind a real-world use scenario that probably all of us can relate to. The structure of the built bridge is entirely realized by flying machines. Every knot and braid in the 7.4-meter, just over 24 feet bridge was tied by the UAV using Dyneema rope. The material has a low weight-to-strength ratio that makes it pretty great for aerial construction uses. That isn't the whole story, though. Before the first ropes are wrapped, the room in question is outfitted with motion capture devices that offer positional measurements that feed back into the custom-made drones. The researchers claim this demonstration as the first effort showing that tiny airborne drones are able to build load-bearing structures at full scale. Now, you can drive a tank over this, but the bridge is definitely more useful than drone-delivered mistletoe. And that is all for Avatar Technology Digest. Thank you for watching us. If you like the content, you're always welcome to subscribe, follow us on social media, leave your comments, and join the global conversation. Take care and see you soon.